Hey guys, hope you're doing well here. This is our section 3.2, the central concept of the mole in chemistry here. So our goal at the end of this is to make sure that we can describe the significance and importance of using this mole. So let's get right to it, and then maybe we can get our calculations figured out. So first, if you remember back to section 3.1, we were talking about this relative mass, and what we saw was in this picture, it took 16 little atoms of hydrogen to equal the mass of one atom of oxygen. So oxygen's a lot heavier. So if we take this reasoning, and then I said if I have 16 grams of oxygen, wouldn't that have the same number of atoms inside of it as just 1 gram if it's 16 times heavier? So that's the ultimate process that we were trying to figure out, the mole idea. Chemists needed to have some sort of unit to help express this many atoms. It's just an incredible number of atoms. So another analogy would, we've done the 1 gram of hydrogen, 16 grams of oxygen, and 63.5 grams of copper would have this. How many atoms are inside of that? So chemists came up with the word or unit, the mole. So if we take a look at the definition, it's a quantity and it's equal to the number of atoms in an atomic mass of any element expressed in grams. So here's our picture. I have a little substance of carbon here, and it's 12 grams. So inside of it, there's this big massive number of 6.02, and we're just going to stop at 0.2 instead of all these decimal places, as you can see here. But that's how many atoms would be inside of that 12 grams. Alright, so it's just a convenient way to use this unit when we're talking about it. The analogy that the textbook talks about, if I say the word dozen, in my brain I automatically go 12. If you say the word mole in chemistry, you go to 6.02 times 10 to the 23rd. And usually we're talking about atoms. You could be talking about molecules, or ultimately you could be talking about anything else. Alright, so let's go into converting with this. So there's two conversions that we're going to try and get through. One is converting from when I have moles and I want to get to the number of items inside of our questions will probably be atoms, could be in one of the question ions, could be molecules, etc. And then the other part is trying to go back to moles from those items. So page 117, could you guys jump there please? Here I have chromium ions, and they're responsible for beautiful colors in these rubies and emeralds. And the question is asking how many of these ions are in 3.5 moles of it. So I'm looking for the number of chromium ions, so I'll just put the +3 symbol there. And then I am starting with 3.5 moles of these ions, so Cr +3. I'm going to use the conversion factor of 1 mole on the bottom so I can cancel out the top and bottom there. 1 mole of chromium ions is 6.02 times 10 to the 23rd ions. So that's where I'm just trying to say what they're equal to each other. So 1 mole of chromium +3 is these many ions, 6.02. And finally, I'll get an answer. So I have the answer of 2.1 times 10 to the 24th chromium +3 ions. And you want it to be in two significant figures because in my question I had 3.5, which is two significant figures. Please try number 3 on your own. And then let's go on to the other option here. The other option is trying to go from the items, could be atoms, could be anything, back to moles. So in this question, we have argon inside of the filaments, and it says how many moles of argon do 1.81 times 10 to the 22 atoms represent? So as you can see here, I have my atoms. That was my initial amount. I got my conversion factor, moles on top this time, and then I get my answer. Try number 3.